of, how do you solve a linear programming problem? Linear programming problems start off as a big old paragraph full of tons of information. And from that information, we need our constraint equations, which is just a bunch of inequalities, and we need an objective function. And yesterday, today, and Tuesday, my main goal is how do we get all of that information from those words? And there's a certain way, if you do it, your life ends up being a whole lot easier. So let's start. Yesterday we introduced this problem, and it was all right. And our main goal was find our objective function. Y'all did great. You said, when you read the whole problem, we found out that we are trying to maximize profit. So I'm going to write P equals, because that's what we're trying to find, the maximum or minimum. And anytime you write an objective function, go ahead and put x plus something y. You're going to put some numbers in front of the x and the y. How do you figure out what numbers go in front of the x and the y? You ask yourself, well, if we're talking about profit, what numbers deal with profit up here? And the only two numbers that deal with profit are the $1.50, change colors for that. So I end up with 1.5 and the 2. Y'all gave me that yesterday. Perfect. Now the next part, and this is incredibly important, is now you need to tell me what x and y equal, or what x and y represent. And so I'm going to say that x is going to equal something, y is going to equal something. And to help you figure that part out, you always want to think of x represents the number of something and y represents the number of something. And so your job is try to figure out, what x, number of what. Now, here's where writing the objective function first helps you figure out what x and y are. When you said profit of $1.50, you get to say, well, what was $1.50? What created a profit of $1.50? And in the problem it said, oh, jump rope created so this is the number of jump ropes.
Mr. Alvis, is your camera on?
Uh-oh. Is it?
Yeah, it's on. It's on. You can see the recording and your other screen.
I can see you.
Thanks.
Because I can't see it. So should I just leave the meeting and then come back in?
Yes.
And if that doesn't work, try restarting too.
Yeah.
All right, thank you.
And so x represented the number of jump ropes, and then what cost $2? Well, what cost $2 was a kickball, so I know that y represents kickball. And this is where we ended yesterday. It's a good place to end as far as the problem, because no matter how difficult linear programming problems are, you have to do this first, and I need to make sure this is doable. Because the next part, that's where things get a little iffy, right? Things require a little more thought. You got to be a little more direct in figuring out what you're looking for. So let's talk about that. The next thing you have to do is you read the problem and you look for what are my restrictions. Now, keys for restrictions. The types of problems, I'm going to give you the types of problems that I've seen. You're talking about they're restricting space. Sometimes they restrict money. Sometimes they restrict time. So, what do we know? What are some or items? Do we have anything that says you can have there's some sort of there's some restrictions we're dealing with? So, what are all you have to do is give me a number. Is there a number that represents a restriction?
1200.
The 1200, right? It says you cannot exceed 1200. So you look for the number that's the restriction, right? And so in this case, the number that's the restriction is the 1200. And we can't exceed 1200, so that means 1200's got to be the biggest. So I get this is less than. And it says the combined production level cannot exceed 1200 units per month. So this is 1200 units, meaning it's the actual item, right? And typically when you have some sort of combined units, you get to say there's going to be an X and there's going to be a Y. And then you need to think about, do I need numbers in front? How do you know if you need numbers in front or not? If this is X and Y represent the number of jump ropes and number of kickballs, and since this is actually representing the actual number of units, I don't need to adjust these, so I get to just say X plus Y is less than or equal to 1200. Now, I think we've used all of this information. Now we read the next sentence and see if can we come up with is there some other inequality? It says the demand for kickballs is no more than 1/2 the demand for jump ropes. So again, they're talking about kickballs and jump ropes. They're not talking about how much they cost or anything else. So I get to just use X's and Y's in almost a direct translation. It says the demand for kickballs, so let's see, kickballs are Y. So I get to say Y is no more than, so that means this side is the biggest. 1/2 the demand for jump ropes. So I get 1/2 the demand for jump ropes, which is X. And the next sentence is the production level of jump ropes, so jump ropes, is less than or equal to, so this is just a direct translation, 600 units plus 3 times the production level of kickballs. So 600 plus 3Y. Now, so I'm just translating, and normally I'd probably want to walk you through and ask questions, but I kind of found out in first period that didn't go so well. So right now I'm just sort of solving it, and then I'm going to ask more questions in the next few examples. We're not done. The reason we're not done is we always have our stupid restrictions, and so my stupid restrictions are everything's got to be positive because we can't make negative jump ropes and negative kickballs. So I'm going to have to say X is greater than or equal to 0, and Y is greater than or equal to 0. And then I'll put my little brace around it. I'll say these are my constraints. I've already got my objective function, so I'll put that up here, which is P equals 1.5x plus 2y. And where I've messed up in the past is I would finish the problem. Like what finish the problem is, graph all this, find your shaded region, find the coordinates, plug the points in, and come up with a final answer. We will do that, just not today, because yesterday, today, and even Tuesday if I need it, is all about, given these words, how do you come up with this? That's the hard part. The rest of this is mechanical, like you can practice it. And actually I've made you practice it. That's what the homework from the beginning of the week was. I gave you a bunch of problems where you had to graph this, then I made you graph this and use an objective function. All right? So, I'm not too worried about the mechanical part. I am worried about how do you translate the words to this stuff. So, let's look at I have an example sheet. Where is it? I have them here. Yeah, this one. All right. I said linear programming 10.1. It's got 3 problems in increasing difficulty. It's maybe not difficult, but they each get more complicated. And we're going to spend a little. I'm actually not going to completely solve these. I'm going to ask questions, and you're going to help me come up with it. But our goal is, for this one, we're going to do exactly what we did the last problem. We're going to create an objective function. You're going to tell me what x and y are. Then we're going to create our constraints. And then after we do that, in theory, and then we'll move on to the next one, because again, today's all about how on earth do we turn these words into our constraints and our objective function. So, with that being said, I'm going to try to be as obnoxious as possible, all right, and see if I can get it out of you guys. So, if you've got it printed out, great. First, can y'all read this?
Yes.
Good, all right. So Jerry works no more than 20 hours a week during the school year. He's paid $10 an hour tutoring geometry students and $12 an hour delivering pizzas. All right? He wants to spend at least 3 hours, but no more than 8 hours tutoring. Find Jerry's maximum weekly earnings. Right? So this is, maybe not as complicated as the last example, but definitely more complicated than what we did a couple of days ago. What do we do? Well, question 1 you ask, what are you trying to optimize?
Weekly earnings.
Earnings. Is everybody okay with that, right? Is it easy to identify that we're trying to maximize earnings, right? That's, okay. So if we're trying to maximize earnings, that's the first thing I'm going to write down. I'm going to write down earnings equals, and every objective function is going to have something times x plus something times y. That's the way they all are. So once you identify you're trying to maximize earnings, go ahead and put something x and something y. And now your job is to figure out the numbers that go in front. So, what numbers go in front of the x and the y? 10 and 12, right? What you think about is what numbers up here deal with earning something. Like in this case, it's money. There's only 2 numbers that deal with money. You got $10 and $12. So I'll make this 10, I'll make this 12. Now, what may not seem very important, and to be honest, it's not that important in this problem, but it will become very, very important when the problems get more complicated, like the last couple. Now we need to talk about what x and y represent. And so x is going to represent something, y is going to represent something. Actually, x is going to represent a number of something, and y is going to represent a number of something. And so now, how you figure out what x and y represent is you actually look at your objective function. Right? If this is 10x, what cost $10? Or what gives him $10? And that's what x equals.
Tutoring geometry for an hour.
Tutoring geometry, right? It says, what does he get $10 for? If this is what he earns $10. What gives him $10? He's paid $10 for 1 hour of tutoring. So x represents the number of hours tutoring. And once you identify what x equals, then it's probably pretty easy to figure out what y equals. So what does y represent?
Hours delivering pizza.
Hours delivering pizza, right? So this represents number of hours, okay, delivering pizza. Okay. And very important stage, because if you get this right, it makes coming up with these inequalities so much easier. Because sometimes these get harder. All right, next up. So now we know that x and y are representing hours. That's important, right? X and y these are hours, right? So when now we have to read the problem, and when we read the problem, we need to figure out what our restrictions are. What are our limitations? Are there any numbers that are restricting what we can do?
You can't tutor less than 8, but it has to be more than 4, so x is in between 3 and 8.
So they're giving, this line is saying he wants to spend at least 3 hours, but no more than 8 hours tutoring. So there's something dealing with x, right? So we're in between 3 and 8, and the way we write that is you have 3 and you have 8, and whatever I put in here is in between 3 and 8, and the red doesn't show up real well. I won't use that one again. Now, it has to do with tutoring, right? So there's an x. And this is the part you have to ask, and right now it's
easy. I can't see the red at all. Can you redo it?
Yeah, okay. Okay. Is that better?
Yeah, thank you.
Okay. All right. So when you have when I stick that x in, that 3 and that 8, those are hours. Right? And if these are hours, I'm going to put a little hour thing here. I have to ask myself, since 3 and 8 are hours, is X measuring hours? In this case it is, so I don't have to change anything. Okay? But that's a question, I'm going to ask a similar question in the next couple of examples, and hopefully it'll make more sense. So we've handled this. Are there any other restrictions? Is there any other limiting number? The 20 hours a week. That's the most he can work. So if that's the most he can work, I'm going to write down 20. And like everything else, 20 has got to be bigger than everything else to the left of it. What's going to go to the left of it?
X plus Y.
Next, because it's just total hours. And since X and Y are still talking about hours, I can go ahead and say that X plus Y has got to be less than 20. And if I'm looking, that's all the information. I've got to put my stupid reasons in, which are going to be X is greater than or equal to 0 and Y is greater than or equal to 0. Then I'll put a little brace around it. And I can put my objective function at the top. And so I end up with my earnings is going to equal 10x plus 2y. And now we have a similar situation as to what we've had in the previous problems. Yes?
Do you still have to put X is greater than or equal to 0, even though we have X in between 3 and 8?
No, technically no. This is kind of, whenever I can, I try to give you something that always works. And I always want you to think about X is greater than 0, Y is greater than 0, but you're absolutely right. X is greater than 0 is not needed because you already have limited here. And that'll show up when you graph. Now, to finish this problem, which we're going to do at a later date, is graph this whole thing, find the shaded region, plug the coordinates into this thing, and then we can find our max or min. But what I've also found in the past, if we finish this problem, we don't get any more practice translating, and we really need the practice translating. So, we're going to go to the next one. Because now these are harder, right? They're definitely longer. There's a lot more information. All right. Wait, can everybody read this? Okay. An Algebra 2 quiz consists of computation problems and graphing problems. Computation problems are worth 6 points each, and graphing problems are worth 10 points each. You can answer a computation problem in 2 minutes and a graphing problem in 4 minutes. You have 40 minutes to take the quiz and may choose no more than 12 problems to answer. Assuming you answer all problems attempted correctly, how many of each type should you answer to get the highest score? All right. There's a lot more going on in this problem than actually in any of the other questions I've given you. Right? So it's very important that we sort of don't look at everything at once. We look at what we need, like what's important at a certain stage. Like the most important thing is, what are you trying to optimize?
Highest score?
Score, right? You're looking for something, like when you're trying to optimize something, it's maximum, minimum, greatest, lowest, high. I mean, you're looking for kind of those extreme, whatever words to describe something that's an extreme. So in this case, it says highest score. So it's telling you, all right, we are going to optimize score. So my procedure is, I'm going to write down score equals, right? And I know there's going to be an X, and I know there's going to be a Y. And now you look through the problem and you ask yourself, okay, what has to do with a score? Look for numbers, because there's a bunch of numbers here. You want to look for the numbers that have to do with the score on your test. And so if you read this whole paragraph, what numbers are dealing with a score on the quiz?
6 and 10.
Right? Because it's like we're looking for points, right? It says you got 6 points each and 10 points each. Okay. So I'm going to put down 6 and 10 because those are what are dealing with points. And now, this is huge. And normally I don't care too much if you tell me exactly what the variables represent, but you really need to tell me what the variables represent with this problem because our inequalities are going to be hard enough if we don't know that. So at this point, now I can write down x is going to equal number of something and y is going to equal number of something. Okay? And the questions you ask, right? Because you've already done most of the work to answer this question. Most of that work came from when you wrote this. When you said 6x, you have to go back and ask yourself, what cost 6? What is 6? That 6 is related to what? That 6 is measuring what?
Computation problem.
Right? Like, what's worth 6? Right? What's worth 6 is a computational problem. So x represents the number of computational problems. And then that means y represents the number of graphing problems. So again, even as ugly as this is, we do the exact same thing. We find the objective function, then we find out what we're trying to optimize, we put x's and y's, we pick numbers for the x and the y. How you pick those numbers determine what x and y are. And now that we know what x and y are, now we can begin to try to figure out the rest of this. Now, there's still a lot of numbers left that we've got to figure out what to do. And what you want to look for is limiting resources. Do you have time? Usually it's time, or air. There's a lot of time or space or something. But all right, can you reading this question? Is there a number that's a limiting factor?
40.
Okay. It says you only have 40 minutes. That's a limiting factor. And so this part's pretty important. So I'm going to put a 40, and that's all I got. Okay, that's 40. And what I'm going to do is I'm going to call this because that's 40, that's time. This is going to be a time inequality. Because 40 minutes is measuring time, that means everything on this line has to deal with time. Now, I think it kind of makes sense that, okay, if we're taking the quiz, we're going to have some of one question, some of another type, right? So I'm going to have this 40 is going to be some combination of x and y, right? But I have a problem. What do x and y represent?
The number of problems.
The number of questions, right? So if this whole little line is supposed to talk about time, this is time because 40 minutes is time. That makes sense. But this is not time. This represents the number of questions. This represents a number of certain questions. This represents a number of a different type of question. So to convert this to time, I have to think, well, how much time does it take to do a computational question?
2 minutes.
Okay? So since it takes 2 minutes to do a computational question, that means every computational question, I multiply it by 2, and that tells me how much time I spent doing computational questions. In a similar manner, I got to think, well, how much time does it take to do a graphing question? I can't remember that. No, it said 4 minutes. Now, looking back at this, and this is the tricky part, is, do you see how this represents a time? This represents a time? Okay? Because if you put that 40 down, you have to say, well, that 40 is representing time, meaning everything to the left better be a time. I just can't say an x and a y because x and y represent number of questions. So to get the time, I have to multiply it by, how long it takes to do each one. All right, next. Do we have another restriction? Is there another number here that's a limiting factor?
12.
We have 12 problems, okay? So I'm going to go ahead and put the 12 here. And that's the max we can do. So I put the 12, and since it's, and it's sort of the combined problems, I'm going to put X and a Y. Because I've got it. Now, since that 12 is talking about problems, are X and Y, do these represent problems as well? Yeah. Because X represents the number of computational problems. This is a problem expression. This is a problem expression. So if I do problem plus problem, that's less than problem. Everything makes sense. I think I got all of the information. I got to put my stupid reasons in, which are X is greater than or equal to 0, and Y is greater than or equal to 0. I get to put my objective function on top, which is S is equal to 6X plus 10Y. And now I have, yes, question? Okay. So now I have my, again, to finish the problem, I have to graph all this, it'd give me a region, plug all the coordinates in here, and we would finish the problem. And we will finish the problem, just not today, because I want to practice translating.
School left.
What? What? Are you okay?
Sorry, my mic was accidentally on.
Okay, all right. All right. And so now we get to the very interesting problem. And this is a problem where learning how to ask those questions helps you come up with the situation, helps you come up with your constraints and your objective function. All right. Now here's what I want y'all to do, and somebody remind me to turn the. All right. So when you read the problem, it says the cost to run machine A for an hour is $2. During that hour, machine A produces 240 bolts and 100 nuts. The cost to run machine B for an hour is $240. During that hour, machine B produces 160 bolts and 160 nuts. With a combined running time of no more than 30 hours, how long should each machine run to produce at least this many bolts and this many nuts at a minimum operating cost, right? There's a ton of information here. I don't care about all of it right now. I care about what am I trying to optimize. What am I trying to optimize?
The cost.
I'm trying to optimize cost, right? It says minimum operating cost. So I am trying to minimize cost. So I'm going to say C for cost. And anytime I write these down, I'll have an X and I'll have a Y. So now we have to read the problem, and we've already identified that we're interested in cost. So I look for numbers that talk about cost. What are the numbers that talk about cost?
2 and 4, or 2 and
240. It's 2 and then 240. Okay? Those are the numbers dealing with cost. And once you've identified your objective function, now you can talk about what x and y equal. And so x is going to equal number of something, y is going to equal number of something. Now, this is crucial, particularly in this problem. A lot of times it's not that big of a deal. This is huge. Right? What does x represent?
Number of hours for machine A.
Perfect. See, and the way you get that is you say, well, you put a 2 next to the x. what does the $2 buy? Right? What costs $2? And this says the cost to run machine A for 1 hour is $2. So this X represents the number of hours of machine A, which means Y represents the number of hours of machine B. All right, this is huge. If you get this, then we can talk about what we write for our constraints. If you don't get this, this isn't going to make a bit of sense. Now, what are some restrictions? Like, what do we have to make?
At least 2,080 volts and 1,520
Okay.
knots.
These are restrictions. This is stuff we've got to make. So what I'm going, and these are numbers, since this is a number for, this is like a number we're going to have to use for restriction. This is another number we're going to use for restriction. So what I'm going to do is I'm going to do the restrictions for bolts, and then I'll have you do the restrictions for nuts, right? So I'm going to write down the 280. We have to produce at least that. So if I want to produce at least 2080, that means this stuff has got to be bigger than 2080, right? And let me move that a little bit over, a little more room, okay? So I have, okay. So there's my 2080, right? It's got to be at least 2080. Now, this is bolts, right? Right, that's how many, so in my mind, I'm going to say this is my bolt inequality. And so everything on this line has to be dealing with bolts. It has to somehow measure bolts, right? Now, I've got, I'm probably going to have X's and Y's because both X and Y are making bolts. So I'm going to put X plus Y, because those are making, machine A and machine B are both making bolts. But if I look at this line, it doesn't make sense, because the right-hand side is dealing with bolts. X and Y are talking about hours. This doesn't make sense. I have to make sure everything is measuring volts, right? Everything has got to represent volts. Now, X represents hours that machine A works. In 1 hour, how many bolts does A make? Everybody see the machine A makes 240 bolts in 1 hour. So every hour, machine A makes 240 bolts, meaning this is going to be 240X. Like if machine A runs 1 hour, I get 240. If machine A runs 2 hours, I do 2 times 240. If it runs 10 hours, it's 10 times 240. Okay, next, I need to know how many bolts machine B is making. And for that one, let's see, how many bolts does machine B make in 1 hour?
$160.
160, right? So I get to put 160 here. And so now what I have is I have my bolt equation. Right? Now, or inequality. What I need you guys to do is I want you to create your nut inequality. Okay? They tell you how many nuts you need to make. So knowing how to come up with the bolt equation makes it easier to come up with the nut equation. So our nut equation is going to be 1520, and let's see, machine A does 100 nuts, so that's going to give us 100x, and machine B does 160, so I get 160y. Is everybody okay? How we got those two inequalities? And you may not believe that, but all of that really hinged on you being able to correctly identify what x and y are supposed to be. Are there any other restrictions? Is there a number I haven't used?
The 30 hours.
Okay, so because you said 30 hours, that means we're having an hour inequality. So this next line is all about hours. Now, I only have 30 hours, so that's the maximum. I'm probably going to use both machines, and so I'm going to say x plus y. Do I need to change them? Do I need to multiply the x and y by anything?
No.
No. Because if you think, because x is representing hours, y is representing hours, 30 is representing hours, everything's measuring hours, so we're fine. The only thing I'm missing are my stupid inequalities, which are going to be x is greater than or equal to 0, and y is greater than or equal to 0. To graph this would take a while. We have our objective function, which is c is equal to 2x plus 2.4y. And we now have kind of like the same results from the other questions. Okay, now let's look at what I want you to do for your homework. And let me pull that up. This is in OneNote. And what I want you to do, at a minimum, I usually don't like giving homework over a long weekend, but I'm giving you 2 problems. And what I want you to do is I want you to set up these equations. We'll worry about solving them, right? But I want you to set up each part. So we're going to start with this one because I want to make sure you're asking the right questions. So read it. Nutrition Center sells health food to mountain climbing teams, whatever. Trailblazer mix package contains 1 pound of corn mixed with 4 pounds of wheat and sells for $9.75. The Frontier contains 2 pounds of corn mixed with 3 pounds of wheat and sells for $9.50. The center has 60 pounds of corn, 120 pounds of wheat. How many packages of each mix should the center sell to maximize profit? Your first question, what are you trying to optimize?
Profit.
Profit, right? So that part's easy. And so you write down P equals, there's going to be an X, there's going to be a Y, and your job is to figure out what numbers go in front of the X and the Y. What are the only numbers dealing with money in this whole problem?
975 and 950.
975 and 950. So I do 975, I do 950. And once you've done that, and this is crucial in this problem, now you can tell me what x and y equal. X equals a number of something, y equals a number of something. And how you answer the question is you think, what cost 975? Because that's what's next to the x. What cost 975?
Number of Trailblazer mix.
The packages of Trailblazers, right? So this is the number of packages of Trailblazer, right? What cost 950? The other one, right? Frontier. Right? This is important. Now, I'm not going to finish this because the bell's going to ring and you got to finish your homework and then I'll upload this video. But I am going to give you a hint on how to start this. What are your constraints? What are some limitations? How much material do we have?
60 pounds of corn and 120 pounds of wheat cereal.
All right, is everybody okay? That's all we have. So if we have 60 pounds of corn, I'm going to put 60 here, and that's the most I have. If I've got 120 pounds of wheat, that's all I have. All right? So that's a huge hint, because when you put a 60 here, that's all you have, what you're saying is this is going to be my corn, inequality, or my corn line. Everything on this line has to talk about corn. Okay? 120, that's wheat. That means everything on this line has to talk about wheat. So, what I want you to do, finish writing the constraint equations with the objective function for this one. Do the same for the second question. And we're going to pick up there when we come back Tuesday. And I may have told you yesterday, we've already made a plan. The test will be not Wednesday but Thursday because I still want to practice this. This to me is important. And one of the main reasons this is important is they ask questions like this on the SAT, and I'm going to show you practice questions from the SAT that require that you know how to do this. So, meaning, if I hadn't spent the week and a half talking about these questions, I don't think you could have gotten these questions right on the SAT. So that's kind of my focus on this. So that's our, and learning to write these equations. Khan Academy has really good SAT practice. They've actually talked with College Board, and College Board has said, here, you're kind of like a platform where we can have, these are very representative of what's on the SAT. And I've pulled some questions from Khan Academy, put them in forms, and you're gonna see what those look like. Anyway, have a nice weekend, and I will talk to you